creating your own classes. So far, we have dealt with built-in classes that come with a JDK, such as string class and integer class and things like that. Here, we want to create our own class. Okay, so we'll see how we can define our own class, and we are going to talk about instance variable and static variable one more time, and same thing with the methods. We're going to look into instance method and static methods one more time. We'll talk about the concept of overloading methods and concept of constructor one more time, and we'll see how we can use what is called the this reference. And then we'll actually talk about the access modifier. So we have seen access modifier of public, and we have seen private, and we haven't seen the example of protected. So we're going to actually see how and when you want to use these different types of access modifiers. Okay? Defining your own class. So the class definition structure look like this. So you're going to specify access modifier, and then you're going to use a keyword of class, and then you provide the name of the class. And inside the class, you're going to have three different types of declaration. One type is attributes. You declare all attributes. So we are talking about variables, okay? And then you're going to have a set of constructor methods, okay? And then you're going to have a set of methods. Okay, so those are three different things that you want to have in your class. Okay, so this is a very simple custom class called a student record. So we say public class student record, and then you're going to have those three different types of declarations. So public is access modifier, and the class is the keyword, and the name of the class is student record. Coding guidelines. Give a meaningful name to your class. That's kind of obvious, right? Okay? So you do not want to use the name XYZ as your name of the class. Okay? So you want to give like a student record as a name of your class. Okay? Class name typically start with a capital letter, but it's not a requirement. Okay? It's a convention that people use. Okay? The file name of your class must have the same name as your class name. This is something that we learned yesterday, right? So if you're creating student record class, you have to have that student record class inside student record.java file. Okay? All right. You can also have multiple declarations in a single file, meaning multiple class declarations in a single file, as we talked about yesterday. Okay? However, there could be only a single public class. Okay, so every public class should be in its own file. So if you want to have a multiple class declarations, then there should be only a single public class, and other classes should be like a protected or private. Okay. Okay, so let's take a look at exercise 1. Okay, so we're going to actually import this project. So I'm going to just create the Java working set. Let's see. Yes. Oh, actually, that is. Okay, so I'm going to import the project. Main project. Okay, so my student record example project. So when you run the project, Yeah, it just give the name of Anna and number of students count. So if you take a look at the code, each class should have the instance variable the variable declarations. So here we are just having instance variable declarations, but you could have static variable declarations as we learned, right? Yeah, okay, so here is an example. So we have instance variable declarations, and then we have a static variable declarations, okay? And then we have the get name method, set name method, and get average method, okay? And then we have a static method, get student count, okay? And then we have increase student count method, okay? Those are two static method example. And then we have a bunch of instance method, get math grade, set math grade, get English grade, and set English grade, and same thing for the science and the get science, set and get a method of these instance fields. Okay. All right. Now, so student record example here we are, so this is the first example. We have in fact two classes. Okay. So that is the student record class. Now we have a student record example class which contains the main method. So this is the one that should have a main method. So it has a main method. Okay. And so we created one instance of student record. Okay, so we create a student record and we call Anna record. Okay, now every time we created a student record, we want to increment number of students that has been created. So here, we are calling increased student count static method of student record class. Now you can see why we want to create increased student count as a static method, because that's not really relevant to a particular object instance, right? So that's the reason. And we want to actually have a same field for all object instances, right? Okay, so we design increase student count as a static method, and we are using student record class to invoke it. Okay, so it will increment the count by 1, and the count should be static variable as well, because if you see count here, it is a static variable. Okay, because this is the count that counts the number of object instances, right? So if you make this one as an instance variable, then each object instance will have a different value. So obviously that's not right. Okay, so that's the reason we actually make it as a static variable. Okay, all right. So and then we created another one, B record, and we again call the increased student count, and we have a quiz record. So we have created 3 students. Okay. And then we're going to actually call the method of, we are basically setting the name of each of these objects. So this Anna record object will have a name of Anna, and the bean record will have a B and the quiz. Okay? And then we are going to just display the Anna's name by calling get name method. And then we also print out the number of counts. So again, this is the static method of student record class. Okay? And when you build and run the application, it will display Anna and 3, okay, as we have seen here. Okay, so for your own exercise, I want you to modify student record example to Java. Create another student record object with a new keyword and name it as my own record. And you're going to use the set name method of my record object, we just created, and passing my own as a value to set. Okay, so that's the name of the student, right? And so we're going to actually display the name of my own record object, and then you set the math grade, you set the English, and basically you want to set this grade, and just providing some values, and then I want you to display the average grade of my own record object. Okay, all right. So I'm going to give you guys about 10 minutes to try this exercise. Instance variable versus static variables. So we touched upon this topic in our previous presentation. So we can actually look into this one from a bit detailed perspective. Okay. So instance variable belongs to an object instance. So the values of these variables of an object instance is going to be different from the ones of other object instances. A class variable, however, that belongs to a class. So the same value is going to be visible to all object instances. So all object instances will actually access the same value of the class variable or static variable. So let's see example of that. So in our example, exercise 1, we have in fact a count that has been used to count the number of objects, number of student record objects, right? So that is supposed to be the value that is common among all object instances. That's the reason we want to create it as a static variable or class variable, okay? The plate number, color, manufacturer, and current speed, those are the instance variables, meaning instance properties, because the values of those are going to be different depending on object instance, okay? However, this counter is supposed to be common among all object instances. That's the reason it is actually a class variable. Make sense? So depending on the need, you want to design your variables, either the class or instance variable. Okay, so let's move on to instance variables. So the way that you define or declare instance variable is access modifier, and then you provide the type and you provide a name, and you can also provide the default values. Yeah, these are all kind of repeat of what we have learned in the past, okay? So in student record class, we have defined a bunch of instance variables, name and address and age and the grade. These are the values that are different from each other. I mean, the object instance of A is going to have a different values of these instance variables from object instance B, okay? So in this case, the private is access modifier, and we're going to actually talk about this access modifier later on. When you set this access, when you set the access modifier of private for your instance variables, that means only in this class these variables can be accessible. That is what private means. Okay? Again, we are going to talk about that in detail later on. Okay, so static variables, you specify with a static modifier. Okay, so again, this is a repeat. Okay, moving forward. Method. The way you declare or define a method is again having access modifier, and then you provide a return type, then you provide a name, and then you provide set of parameters or arguments, and inside you have a Java statement. Okay. Okay. Now that is actually what is called the getter method or setter method. Getter method sometimes is called the accessor method. Okay. So this getter method is used to get the value of your instance or static variable, right? And it's typically written as a get and name of the instance variable, right? For example, suppose we have a name field, and the accessor method of the name field is going to be get name, and it returns a string object, and basically returns the name string object. Okay. So in this case, this getter method is just like a regular method, okay? And it is a public access modifier, meaning some other classes can access this method. And then return type is string, and this is the name of the method. It doesn't have any arguments, and internally it has a single method. Only thing it does is just return the name value. Okay, so this is the accessor method. Okay, so accessor method does not need to, in fact, use the properties. If you have a get average method, it might actually just compute something and just return, okay? It doesn't have to just return the value of a particular field. Okay? This is another example of getter method. Okay, now there is what is called the setter method or mutator method. So this setter method is used to change or set the value of a variable, and the convention is set and the name of the variable. Okay, so for name field, the setter method is set name, and then it should actually receive a string argument, right? And that argument will be used to set the name property. Okay. One thing I want you to remember is that the setter method and getter method, typically the name of your variable is going to be in lowercase, okay? However, getter and setter method should have capital. After get and set prefix, it should have a capital, the letter for the field. Okay, set name and get name. So those are, like I said, get average, or in this case, get name. Okay. The reason this is actually useful is because because of what is called the Java bean convention. Okay, so if you follow this convention, then the tool can actually take a look at the bytecode of this student record class file, and it can figures out there is in fact the getter method of get name and the setter method of set name. It actually figures out there is actually a property called the name. Okay, but if you actually have a get and small letter name, then it's not going to be able to understand that. Okay, so we haven't talked about the concept of reflection yet. Reflection is Java technology that could be used by the tool. So from the bytecode, meaning from the class file, it can figures out what set of methods are available. Okay, and by using reflection, it can actually see there is a get name method and there is a set name method. And from that, it can figures out that there is in fact a name property. Okay. Any questions on getter and setter method? Question: what is a Java bean? Okay. Yeah. So we have a presentation on Java bean, and I don't think we have time to cover Java bean. But so since you actually asked, let me just kind of talk about Java bean a bit. Okay. So a Java bean is basically a regular Java class that that follows some kind of convention. So it actually so whenever there is a property, the field itself is going to be field, the private field. However, you have a getter and setter method. Okay. So the Java bean is a regular Java class that follows some convention like that. So there is a getter method and setter method, and then the tools will take a look at the Java bean by using reflection, and then tools should be able to, let you use the tool. The tools let you, in fact, change things without actually writing code. Okay, so typical Java bean object could be some kind of UI object. Okay, you could in fact have a text field Java bean object, or you could have slider object and things like that. And the properties of those Java bean object could be actually changed from the GUI front end. Right? All right, so let me actually stop right there, because so Java bean is actually pretty useful kind of the class convention. Right? So hopefully they keep a little bit of sense of what the Java bean is all about. A question from Carlos: would you explain a bit on get, set, and get? Okay, let me actually take a look at Roger's question, see whether they are pretty much the same. Do we create getter and setter method for each data member? In general, that's a good practice. Okay, but there are cases you want to have just a getter method, which means there is a way to get the value, but you do not want to allow the property to be changed. In that case, you provide only a getter method. Very rarely, you might want to just provide the setter method, but not getter method. In that case, you want the user to be able to set the value, but not being able to actually get the value. Okay. If you want the user of your class to be able to either get and set a property or a field, same thing, and then you want to provide both getter and setter method. Okay. So Carlos, I'm not sure. Carlos, let me actually move on, and we might in fact some examples in the hands-on lab to actually give you a sense of why this getter and setter method could be in fact a bit more useful. Question from Dimitri: did we explain about the constant vars? Constant vars. You mean how to set the constant value? Like an enum and the things like that. That's something we might actually cover later on. Okay? Yeah, we're gonna cover that later on. Okay, so moving forward, multiple return statements. So you could actually have a multiple return statement. So in this example, depending on the value of num, we just return one string object. If the num is 2, we return 2 string object. Other than that, we just return default num, which is 0. Right? So you can have a multiple return statement. However, the logic should return a single, return object, right? Okay, so during runtime, it will return a single return object. Moving forward, static methods. Okay, so static method has this prefix of static. Okay, so again, we have actually learned the static method, instance method in our previous presentation a bit, right? Okay, so here we want to get the number of student count. Okay, so that's the reason we want to actually make this guy as a static method. Okay, so coding guidelines for method. Method name should start with a small letter. Okay, just like a variables. And method names typically should sound like a verb. Okay, property should be sounding like a noun. However, method name should sound like a verb. Okay, but again, this is just the recommendation. And typically, you want to provide some documentation for the method using java.style. Okay, so source code of student record class. So this is pretty much what we have seen in our previous exercise, right? Okay, so these are the set of instance variables: name, address, age, and math grade, and all that stuff. And they are all different. They are different depending on object instances. And this is the getter and setter method for these properties. So in general, you want to make all your instance variables and static variables as well typically instance variable to be private. You don't want to allow direct access to your private properties, okay, these properties. So instead, you want to provide a getter and setter method. Okay, so these getter and setter methods are only way for the user of your class to be able to access your property. Okay? The reason is this: if you allow direct access to this instance variable, like if you make this guy as a public, okay, and suppose there are 5 classes that actually directly access to this guy, okay. The problem is that if you make a change, suppose you change the name of the variable, then you have to actually go out and change all those 5 classes that directly access this name. And that could be a chore. I mean, make it like 1,000 classes. If there are 1,000 classes that can directly access this name field because you make it as a public, then if you change this name to be, name of this variable to be name XYZ, or my name or something like that, then you have to actually go out and change this, the 1,000 classes that directly access that field. And that's pretty much, that's a spaghetti code, right? Now, if you make this guy as a private, and what that means is that the only way other classes can access this name field is by using this get name, right? Get name and set name. Now, suppose in the future you want to change the name of this field to my name. That should not affect this rest of the code because they're gonna still be able to use this get name method call. And only thing you have to change is basically the implementation of this get name as well as a set name method. You're gonna just change this guy as a return my name, and then here you're gonna actually use the temp and assign to my name. So you can actually change this getter and setter method, and all the classes that use this get name and set name do not need to be changed. Do you see that point? Question on that? So that's pretty important aspect, in fact. In fact, that's encapsulation. You are encapsulating implementation detail of get name or set name inside this method. So the caller of this get name does not need to know how it is implemented. For example, another example is this. For example, the get name. Today, you are just returning the name field value here. Oops, sorry. You are just returning the name from the property value. However, in the future, you might in fact actually perform some kind of a web services call to another server to get the name. You might in fact actually perform database operation. Okay, so you can change the implementation detail of getting the name value within the get name. However, that does not force classes that use a get name to be changed. That is the benefit of encapsulation. If you allow other classes to be able to access this name directly, then you have a problem. You are not really encapsulating the implementation detail. Does that make sense? Okay, question from Roger. What is encapsulation? So that's something we talked about yesterday. Encapsulation is basically hiding implementation detail. Okay, so suppose if you have a class, that class is going to be used by somebody else, right? Okay, so implementation detail class or implementation detail of your class is hidden from the user of the class. So let's actually get back to the like a string class. We don't care how strings methods are implemented, right? We just use that methods of the string class, right? Yeah, we don't care how it is implemented. In fact, in the future, it's possible the string class implementation might in fact change internally, okay? All we know is that, we can just call the method, okay? So, in that sense, the implementation detail is hidden in the string class. In our case, it's a student record class. That's encapsulation. So Roger said, so you hide the information. Well, you basically hide the implementation detail. So that's probably a better way of saying it. Does that make sense? Okay, good. Any other questions? All right, so let's move forward. Okay, so this is a sample code that uses the student record. So this is something that you worked on in exercise 1. So this is the instance method and this is the static method. Okay. Okay, so now I think one question that was asked before was, how do you make a decision in terms of, I want to create this method as a static method, or I want to create this method as the instance method. Okay. So these are examples. When the logic and state does not involve specific object instance, then you want to create it as a static method. So computation method is a good example. So if you want to actually perform some kind of computation with two given numbers, like x and y, okay, then it's probably a good thing to create add as a static method because it doesn't have to be dependent upon a particular object instance. Okay, so we have a computer class, and computer class will have add, subtract, and multiply, whatever. Those methods could be created as a static method because anything that is relevant is actually be received as arguments. Okay? All right, so there is no object instance needed. So that's the reason we want to create add, subtract as a static method. And we also have seen an example of, if you want to create some kind of logic as a convenience method, for example, converting a string into an integer. There is no need to have an object instance of integer object, right? Basically just receive a string object and then convert into int type, right? So again, this is a convenient method that could be designed as a static method. Okay? So does this make sense? All right, so let's actually take a look at exercise 2. Okay, so here we're going to exercise. We are going to, in this case, we create a variables class, and we have 2 static variables and 2 instance variables. Okay, and then we have static variables, example.java, that actually use this class. Okay, so for static method, we can just call those things right away, right? For instance method, we have to create object instances and then call. Okay. By the way, static variables can be accessed from object instance as well. Okay. yesterday when we try to access instance, I'm sorry, was that static method from? Yeah, so you cannot access the instance method from a static static method. So what I'm talking about. Yeah, what we have seen is within the static method you cannot actually access instance method, right? So that's something we have seen. But the static variable can be accessed from object instance. Okay. Yeah. So so that is an exercise of this guy. Okay? They basically share the same variable. Okay? Observe compiler when you try to access instance variable as if it is the static variable. So yeah, so this is something I think we have done as well. Okay? Yeah, just try that. And 2.2, we are going to build and run the application that uses the static method and non-static method. So here we have defined, the methods class, and then we have a static variable, and then we have a static method. Okay, static method could be anonymous or it could have a name. So this is a case that we have a name. Okay, but you could also have an anonymous static method. Okay, so basically this method gets executed when the class is loaded. Okay, so you could actually use this anonymous static method to perform some initialization. So in this case we are just anonymous static method entered, and we are just increment by 1 the static variable, and then we just display again. And this is non-static method, instance method. Okay? Then we have static method example class. So here we are basically accessing a static variable, and we call the static method, and then static method can be invoked from object instance. Yeah, so this one is okay. You can access the static method from object instance, but you cannot actually do the other direction. Okay, and then same static variable can be accessed from multiple object instances. Okay, so you can just build and run the application. Okay, so I'm going to give you guys about 5 or 10 minutes to do exercise 2. So let's move forward. Next topic is overloading methods. So what is method overloading? So methods with the same name but with a different number of arguments, or even if they have the same number of arguments, if the types of arguments are different, if there are multiple of those are called method overloading. Okay, so as long as they share the same name but with a different argument, the signature, then they are called overloaded method. So why you want to use method overloading? The reason is because you want to provide multiple implementations depending on the set of arguments, but want to share the same name. So it's kind of a way of grouping similar implementations, but different implementation based on arguments. So overloaded methods have the same these properties. They share the same name, okay, same method name, but the different number of parameters or different types of parameters if they have the same number of parameters or arguments. Return type can be different, however. So let's say an example. So in a class, you might in fact have two different implementation of print method. The first print method receive a string temp, and the second print method receive different set of arguments. Okay, so these two guys are called overloaded methods. Okay, so they do something similar, but they certainly have a different behavior depending on arguments it receives. Okay, how you call the overloaded method? So basically, you are going to call overloaded method by passing arguments that that it's aligned with a particular overloaded method. So in this case, when I call print with a single argument, it will call this guy. When I call print method with 3 different arguments, with the types that are required for this method, then it will call this guy. So when you call the overloaded method, the Java compiler and the runtime system knows exactly what to call, because it can take a look at the argument signature and it knows which one to call. So you can think of overloaded method, it's just like a regular method, but turns out, they basically share the name of the method. Okay, exercise 3. So I'm going to just show you how the exercise 3, and we'll just move on. Okay, so exercise 3. So here, we're actually using the same example, the print method. We have, in fact, they have 3 different myPrint overloaded method. This one doesn't take any argument. This one takes name argument, and this one takes name and average grade arguments. Okay. And in example code, we can call the different myPrint method. Okay, and it's pretty straightforward. So let me just move forward. Constructor or constructor methods. What is a constructor method? It is a special method where initialization of newly created object is done. So constructor method is invoked when an object gets created. Okay? So the differences from a regular method is that constructors have the same name as the class, and constructors do not have any return value. And you cannot call constructor directly, of a particular class. It gets called only when you try to create an object instance of a particular class. So it gets called internally by the runtime. So the way you create a constructor method is you specify modifier and you specify the name of the class, and then you can have a set of arguments. Okay, and internally you could have Java statements. So the concept of default constructor or default constructor method. Okay, so the default constructor method is basically a constructor method which takes no arguments. So that's the reason it's called the no arg constructor. So as we talked about yesterday, if class definition does not have a constructor method, then default constructor gets created automatically by the compiler. Okay, so in the case of student record class, this is the default constructor. It's a constructor that takes no arguments. Okay. However, if there is already a constructor, meaning your class definition have a constructor, whether that is a no-arg constructor or none, or arg constructor, then default constructor does not get created by the compiler. Okay, so default constructor gets added only when there is no other constructor present in the class definition. Make sense? Okay. Okay, so constructor methods could be overloaded as well, meaning there could be multiple constructor methods. So in this example, we have no arg constructor on the top that doesn't receive any arguments, and then we have a student record constructor that takes the string temp, and then we have another one that takes the name and address, and then the fourth one takes the grade. It grades. Right? So we have 4 constructor methods in this class. The way you can use the constructor is, again, depending on the arguments you pass, different constructor will be invoked, okay, internally. So in this case, when I create student record object, okay, the compiler will, the runtime will certainly take a look at, is there any constructor that takes string value? Okay? And obviously we do have one, so this constructor will be used. Okay? In the case of this guy, we are creating student record, passing the name and another string object. So in that case, this constructor method will be used. Okay? In the case of this guy, it passes the 3 integer values. So in that case, the constructor method of this guy, yeah, is a double value. So constructor method of this guy is going to be used when it creates a student record object. Is that clear? Okay. This constructor call. So there is actually a special method called the this. Okay. So the constructor calls can be chained. Okay. And meaning you can call another constructor method within a constructor, and you can actually use this call for that purpose. Okay. But there are some rules to follow when you're using this constructor call. It has to be used only in a constructor method. You cannot use this call in regular method. And it has to be the first statement in a constructor. Otherwise, it's a compiler error. Okay? So let's see an example of this. So suppose we have a two constructor method. Student record doesn't receive any, the first one doesn't receive any arguments. The second one receives a single argument. Okay, so we have a two overloaded constructor methods. And now, when we call new student record, it obviously will actually call this guy, right? But, we want to set the default value. In this case, we are going to use the this method. Okay, so we're going to actually set the something, and then this will call this guy. So this is actually used, when you want to actually set, in this case, some default values. So if user pass in like a student record and pass some string value, then this this second student record constructor will be used. However, if in this case no string is actually passed as an argument, but you want to still set some kind of the default values like some string, then in this case, within this student record constructor method that gets called here, and then we are going to call this method, which calls this guy to set the name with this temporary value. Okay, so this is an example where this is actually used. Okay, question from Joel. Is what you just posted an example of chaining constructor? Yeah, so this is the example of chaining, sorry. This is the example of chaining constructor methods. Does that answer your question, Joel? Yeah, okay. Moving forward. Okay, so exercise 4 is constructor. So, yeah, so here we have created, we have created 5 constructors. So, NOAA constructor and constructor with a single parameter, 2 parameters, 3 parameters, and 4 parameters. Okay. And in the example, the Java that contains the main method, yeah, so we created, yeah, so student record object, and yeah, so this is pretty much the same code, okay? But depending on what you're passing, when you're creating a student record object, different student record constructor method will be invoked, okay? Yeah, so that's pretty straightforward, okay? Yeah, so and for that too is chaining. So you're chaining constructors via this method. So here we have, we have default, and then we have student record takes one single argument, and yeah. So in this case, basically, when this student record, constructor method is invoked, instead of directly setting the name field, we want to actually call this guy. Same thing for this guy. So when you have a name, grade, and e-grade, so instead of actually setting these things directly ourselves in this constructor method, okay? So that's kind of duplication of the code in a sense, right? So instead, we want to call another version of student record, okay? So that is basically chaining. All right, so I'm going to give you guys time, 10 minutes to do exercise and 3 and 4. Next topic is this reference. So this reference is used to refer current object instance. So this is actually used to access instance variables, or even actually instance method as well. So basically the way you can use this is that you can use this that represent current object and then name of the instance variable. So sometimes you actually see a method like this, set age, and you receive the age, and then you actually see this.age and age. Basically you are using this argument to set this object age property. And this is in fact the same thing as this. Okay, so when you do not use this dot, that's assumed because you're talking about the current object. But if you want to use this dot, that's allowed. Okay, so this is the same thing as this. Okay. You can only use this reference for instance variables, not static variables. That makes sense because this is referencing object instance, right? So you cannot actually use this to access static variables. Okay, so even for method, this reference is in fact assumed when you call a method. So suppose I have my class definition. It has two methods. One is called the A method, and the other one is called the another method. Okay, so when you call another method within a method, so basically a method calls another method, right? So this is in fact the same thing as this dot another method. You never actually see this kind of syntax, right? Because there is no reason to use this dot in this case, right? But it is syntactically it's okay, right? So this is in fact same thing as this. Okay, so let's take a look at exercise 5. So the this is basically the same thing. Okay, so we call the my method 2, and then we call the this.my method. So this is in fact doing the same thing. Okay, and this one is study this reference example. Oh, okay, so this is the dummy class, and we are basically creating dummy class object, and then we call the my method 1. So it's calling my method 1. And then here is actually calling my method within the my method 1 is calling my method 2 twice. It just shows that the method could be accessed through this dot notation. Okay? Pretty straightforward. Now you are going to modify the dummy class.java. So now we're going to actually add static method. So within the static method, if you try to call instance method, that's a compile error. Okay, so we know that from the static method you cannot call instance method. Okay, so you will experience compile error. And 5.2 is usage of this reference. Okay, so in this case, this is the my method 1, and so here we actually we created another method called the my method 3, which received the object type. Okay, and then we call we just get the class object, and then we get the name of that class. Okay, so in this case we are just passing our the current object by passing this. Okay, and let's see what it displays. When you run the application, it should actually display the dummy class. Okay, because that is this is basically this object. Okay. Then obviously the class of it should be actually dummy class. Okay. Okay. So here now we created two instance properties or variables, hello and by. Okay, and then we can actually call this.hello and this by. So basically you can use this as an object. Okay. All right, so when you run the application, it will actually display this information. I'm gonna actually let you kind of, digest this a little bit. Okay, this is probably not that much critical. I mean, you rarely use this fashion. Okay, yeah. All right, so let me actually finish up the presentation, and we'll do exercise. Yeah, we'll do the rest of the exercises for you. Okay, so access modifiers. So this is probably more important than this and the previous two topics, actually. The access modifiers. So there are 4 different types of the member access modifiers: public, protected, and the default and private. So public is the least restrictive, it's most open, while private is the most restrictive, meaning the least open. Okay. By the way, the public and protected and private, those are you explicitly specify for the class members, like a method or properties. However, the default, there is another one called the default, and that's called the sometimes package private. Okay. So this is actually the default, which means that when you do not specify any access modifier, that's the case, that's the default, or sometimes called the package private. Okay, so let's talk about each of these in a bit more detail. So we are mainly talking about the class members, the properties, and the method. So when we set public access modifier for property or the method, what that means is that this property and this method can be accessed inside and outside of the class and outside of the package to which this class belongs. Basically, everyone can access this property and this method. And again, usually the good practice is that you want to make your property private, but you want to make the getter and setter method, access or mutator method, public. Okay. That's public access modifier. Protected access modifier is something we haven't used yet. It specifies that the members, meaning this property and methods, are accessible only to methods in that class and the subclasses of that class. So, there could be subclass from the student record, so that those subclasses of the student record class should be able to access this name and get name properties. Okay. However, the subclass can be in different packages. Okay, so that's protected. Now, default access modifier. If you do not specify any access modifier, then it's set at with the default access modifier. It's sometimes package private. What that means is that these members, this name property and get name method, will be accessible in any classes within the same package. So that's the reason it's called the package private. So it's private within the package. So that is a default. Okay. And the private is that, these members are accessible, only within this class. Okay, so, this get name method can access name, okay? And there could be another method that actually called this get name. But these members, name property and get name, are not accessible outside of the student record class. Okay, so that's private. So if you actually see the scope of visibility or accessibility, I mean, this is basically what, if you set a member, a class member like a property or a method name with a private, then it can be accessed only within the same class. A default or package private, it can be accessed within the same package. Okay, and the protected is that it could be any subclasses, and that subclass could be in a different package. And public, anybody can access the public members. Does this make sense? Question? Any questions on this? Okay, so moving forward. So coding guidelines. As I said before, the instance variables of a class should be declared private, while class should provide public getter and setter method, or access or mutator method. Okay? All right, that is exercise 6. So let's take a look at the exercise 6. Okay, so here we have created dummy class, and we have a private property, and we have protected property, then we have public property, then we have a default property. So we are exercising all 4 different access modifier, okay? And then we also have the same thing in terms of method. We have a private method, we have protected method, and we have default package private method, and we have this is public method. Sorry about that. And this is the default access modifier. So meaning package private. Okay. All right. So we have defined basically properties and the methods with all these different access modifier. Okay. And let's see whether we can access these things. Okay. Okay, so we created a dummy class object. So, we defined the dummy class here, and we created a dummy class object. Okay, now we try to access a private variable, and that's going to cause a compile error. You cannot access private member of another class. Okay, so it's a compile error. Okay. Now this one, if I try to access S2, that's a protected variable. We should be able to access it because the class main and the dummy class are in the same package. We are in the same package. My access modifier project and my access modifier project. So these two classes are in the same package. So we should be able to access a protected variable. So this one should work fine. Okay, and of course, you should be able to access a public variable. And also, we should be able to access the default modifier variable because this class and the dummy class are in the same package. Okay, same package, and the default is what is S4? But this is default mode. Can be accessed within the class in the same package, and the protected. Protected means which one is S2? Protected. So can be accessed within the package. Also can be accessed by subclasses of this class, even if the class is in the different package. Yeah. So as long as it's in the same package, should be accessible, and also even the subclasses in different package can access protected the field. Okay. So that should work fine. And again, in terms of method, that should also work pretty much the same way. Okay. All right. So the now basically you want to actually experience the compile errors. Okay. This one and this one, you just uncomment it and see whether you experience the compile errors. Okay. And now 6.2. Now you're gonna actually try to access modifier from a different package. Okay. So we're gonna create a brand new package called the my new package. Okay. So here in NetBeans, you should be able to actually say right-click new and Java package, okay, and then you provide my new package, okay, and you're gonna create dummy class 2 under the new package, okay, and then so this class, dummy 2 class should be on the my new package, and now we have to actually import dummy class because they are in different packages. Okay, so we can actually talk about the concept of package and importing all those things in our next presentation. If you're using a class in different package, you have to import that class, okay, or a package. So yeah, we are actually importing the dummy class, and then we created dummy class object within the dummy class 2 constructor method. So we created dummy class. And here now we're actually experiencing accessing the dummy class properties and methods, okay, and and see take a look what's happening, okay, and see whether it's actually behaving as expected, okay, and then we create another class called the dummy class 3 on the my new package, okay, and then we are going to actually access what is the what is the S1? This is actually interesting. What is the S1? Accessing private variable of dummy class. Yeah, looks like there is some code missing. Within the dummy class. Oh, I'm sorry. Yeah, so this is actually dummy class is extending dummy class. Okay, so I missed that. Okay, yeah, so we haven't talked about the inheritance yet. So you can see dummy class 3 is a child class of dummy class. So that's the reason it can access S1, S2, and S4. Those are actually from the dummy classes itself. Okay, so we are basically exercising the, we're accessing those properties of a parent class, and we're actually doing the same thing. We're accessing method 1, method 2, and method 4 from the dummy class. Okay? So again, depending on how the access modifiers are used, how access modifiers are set for the methods and properties in dummy class, it will actually behave accordingly. Okay. Okay, so that is pretty much I have on this presentation. So I'm going to give you guys about 10 minutes to finish up the exercise 5 and 6.